Hey, this is Mr. Aiden. This is the 2023 AP Chemistry exam, the newly released 2023 AP Chemistry exam that was taken on May 1st, 2023. This is free response question number 2 for all your AP Chemistry needs as a teacher or student. Just go to www.mraiden.com. So here we go on question number 2. Question number 2 is a long 10-point question, and you can see it's something about aluminum chloride here. Aluminum chloride is breaking down into aluminum gas and 3 chloride atoms. And the first thing they want to know is how many grams of chloride could be formed from 1.25 moles of aluminum chloride. Well, first we got to start off with our molar ratio. For every 1 mole of aluminum chloride, there's 3 moles of chloride, which means for every 1.25 moles of aluminum chloride, there's 3.75 moles of chlorine. And you take those 3.75 moles, you multiply by its molar mass, and we get 133 grams of the chlorine. And well, this reaction turns to a Hess's Law type problem. You can see they gave us 3 reactions, reaction 2, 3, and 4. And we're trying to find out how can we make the reaction number 1. Well, the first reaction, reaction number 2, we got to flip it because we need that aluminum chloride on the reactant side, on the left-hand side, which makes the delta H, the enthalpy, become positive 583. Reaction number 3, you can see the aluminum gas is already on the products, which means there's 1 mole. We're going to keep it the same, positive 326. Reaction number 4 is a little bit more difficult. We have 2 moles of chlorine gas. We want 3 moles of chlorine gas. So we have to multiply that by 3 halves, or 1.5, which gives us a delta H of positive 364.5. You add all those up to make the final reaction, and that's positive endothermic 1273.5 kilojoules per mole. You can round to the correct significant digits, or you can just kind of leave it at that. Then next, they give us a internuclear distance graph where we want to find out the bond length of the Cl2. Well, we're going to take the lowest potential energy, which you can see that lowest potential energy is at 200 picometers, and it takes 250 kilojoules in order to break that bond, and so 200 picometers. And then they asked us in the second part to draw what the Al to Cl bond length would look like. And that they gave us the bond length of 220 picometers and 425 kilojoules per mole. So we're going to put our peak at 220 picometers and 425 kilojoules per mole. And it will look very, very similar to the first graph, except shifted to the right and shifted down, of course. And then we go to Lewis dot structures. You can see this problem has all kinds of stuff. It's almost different every single part. And the first thing they ask us is, which diagram can be eliminated based on geometry? We want aluminum chloride to have a trigonal planar geometry. Well, diagram 1 and diagram 3 are good. They have 3 electron bonding domains, 3 bonding sites, sp2 hybridization. They're both trigonal planar shapes, but diagram 2 has that extra unshared pair of electrons, which makes 4 electron bonding domains, sp3 hybridization. It would be a trigonal pyramidal shape. I'm sure they would take any one of those answers. That would be justification for eliminating diagram number 2. And then they say, according to formal charges, which is the best diagram? Now, we've already eliminated diagram 2, so it's really between diagram 1 and diagram 3. We want the diagram with a formal charge of 0 on all the atoms, which, of course, is diagram 1. Diagram 1, you can see chlorine has 7 valence electrons. It has 7 valence electrons around it, which means 0 formal charge. Aluminum has 3 valence electrons. It has 3 electrons around it, a formal charge of 0. Diagram 3 has formal charges on different elements. One of the chlorines has a positive 1 charge, one of the aluminums has a negative 1 charge, and that ain't good. So diagram 1 is the best diagram. And then it turns to an equilibrium problem. First, they ask us for the Kp of this reaction. How do we do a Kp? We put the products on the top. That's the pressure of Al2Cl6, the pressure of the aluminum chloride on the bottom, but we have to square it because there's 2 moles of the aluminum chloride. And then they give us a kind of a partial pressure gas law problem where they told us the total pressure is 22.1 atmospheres. We'll take a look. There's only 3 out of the 10 particles is the Al2Cl6, which means 3/10 of 22.1 gives us a partial pressure of 6.63 atmospheres. You can see the aluminum chloride, there's 7 out of the 10 particles of 22.1 atmospheres. It's 15.47 atmospheres. We take those 2 values, we plug it in our equilibrium expression that we got in part E, and we get a Kp of 0.0 0.0277. And that is the 2023 AP Chemistry exam free response question number 2. Check out MrEden.com. I'll see you for number 3 later on.